Hey there, in this video we're going to be looking at total resistance, which was requested by Lina Kalelo that wrote, "Can say as well drop 1 for calculating total resistance." Now once we are done explaining total resistance, we will also look, as promised in the previous video, we'll also look at a simple circuit, okay? How to calculate questions related to resistance in a simple circuit. Now without further ado, let's dive into this video. Welcome to Rise Up Namibia. My name is Met Yanata, aka the Resistor of Bad and the Love of Good, hashtag dark and lovely _ walk by faith and not by sight. So, what do you do when you have certain resistors connected in series? For example, like the one we see on screen. Now something like this is very easy, because what you do is you use this formula, which is the total resistance is equal to, since we have 3 resistors, we just add them, okay? Which is resistor 1 plus 2 plus 3. So if you add the 3 resistors, you will have, the first one is 7 plus the second one, which is 1, and then the third one is 2. So what is 7 plus 1 plus 2? That will give us 10 ohms, and that's your final answer, okay? Now what do you do when you have 2 resistors connected in parallel? For example, this 2. This one is actually also very easy, because what you do is you use this formula. So it says the total resistance is equal to the product of resistors divided by the sum of resistors. So what does this mean? Think of it in mathematics. When we say product, it simply means you multiply the 2 resistors. So the product on top, we say 6 multiplied by 4. And then as a denominator, the sum is like addition, we are adding. So it will be 6 plus 4 at the bottom. Okay? So 6 times 4 is 24. 6 plus 4 is 10. Now what is 24 divided by 10? That will give us 2.4 ohms. And that's your final answer. Okay? Now what happens when you have 3 resistors in parallel? For example, like this. Now before we check on how to calculate the total resistance of these 3, how are you finding the video so far? Is it helpful? If yes, please do support the channel by giving us a huge thumbs up and subscribing. Okay? Back to the lesson. Now for you to find the total resistance of 3 resistors, we use this formula, which is by putting 1 over the total resistance equals to, and then we check how many resistors do we have? 1, 2, 3. So we basically add those 3, but we put them over 1. Okay? So let's do that. Since the first one is a 6, we put it over 1 over 6. And then the second one is also a 6, so we say 1 over 6 as well. And then the third one is a 3, so we say 1 over 3. Then what do we do from here? We want to make the denominator the same. We don't want to have 6, 6, and 3. So we want to make this denominator the same. How do we do that? By using the lowest common multiple. So let's write down the multiples of all the denominators. So the first denominator is 6. Here is the multiples of 6. The second one is also 6. So we write down the multiples. And the third is 3. So the multiples of 3 is here. 3, 6, 9, 12, 15, and the list goes on. Okay? Now, we want to find the lowest common multiple. What does this mean? Which number is the lowest but common in all 3? So if we check here, we have 6. 6 is the lowest common multiple. Okay? So it is in all 3. So 6 becomes our denominator, our new denominator. Okay? Now when you make 6 the new denominator, there's something else that you should do before you continue. Check the numerator. Let's check the first term. The first term was 1 over 6. Okay? So now, what was the numerator? The numerator was 1. So we take that numerator as 1 and then we write it down. Then we multiply it by 1. Why did we multiply it by 1 here? Because when you check in the multiples of 6, which was the old denominator here, how many figures did you move to reach the lowest common multiple? We only moved 1. So the numerator that was there, which is this one, we will multiply it with 1. Okay? The same goes for the second term. The second term, the numerator was also 1, so we write down 1 multiplied by 1. How come we are multiplying it again by 1? Because in the multiples here, we only moved to 1 to reach the lowest common multiple. But then the third term, we had numerator 1, so we write down numerator 1 multiplied by 2. Why do you think we multiplied this one by 2? That is because in the multiples of 3, we moved 2 times to reach the lowest common multiple. So which means we moved 1 from 3 and then 2 to reach 6. So that's why we say 1 multiplied by 2. So obviously from here, if we work that out, 1 multiplied by 1 will just be 1 plus another 1 multiplied by 1 will give us 1. And then 1 multiplied by 2 will give us 2. So we divide that by 6. Remember here we made the denominator the same, so it still remains 6. So if we say 1 plus 1 plus 2, it will give us 4. And then that 4 is divided by 6. But now, remember we are looking for the total resistance, meaning we want RT. So what do? Let's invert or change the denominators into numerators and then the numerators into denominators. How do we do that? We flip them. Remember now the denominators was RT and 6. We change them into numerators. And then the numerators was 1 and 4. So we change it into denominators. Okay? So from here we know that RT divided by 1 is just equals to RT. How do I know this? Even in your calculator, if you press any number divided by 1, it will just be that number. Say for example, you say 5 divided by 1, you will just get 5. Even if you say 100 divided by 1, you will just get 100. So RT divided by 1 will just be RT. And then 6 divided by 4, you will get 1.5 ohms. And this is simply your final answer. Okay? So the tricky part really is just getting to find the lowest common multiple here. And this is done, we have done a video, I remember, for mathematics where we did the addition of fractions. So if you didn't understand what I did here, I'll put a link down below in the description on how to add fractions, okay? Because when you're adding fractions, you always do need to make the denominator the same. Okay, now with that said, let's look at this example. So I want you to pause the video and then use the formula that we have learned so far in the previous videos, as well as some knowledge from this video, and try answering A, B, C, and D. Okay? So pause the video now. Okay, so it reads, in the following circuit, the resistance of R1 is equals to 2 ohms and R2 equals to 4 ohms and is connected to a 12-volt battery. Number 1, calculate the total resistance. Okay, so now the first question asks us to calculate the total resistance. Remember in this video, the first example, we had 2 resistors in series. Now since these 2 are also in series, what do? We simply add those 2 resistors. Okay, since resistor 1 is 2 ohms, we write down there 2 plus the resistor 2 is 4 ohms. And then we'll get what? The total resistance will be 6 ohms. And that's your final answer. So let me just move this to there. Okay? So let's clean up here and solve for B. So what does B state or ask? B is asking us to calculate the amount of current that flows through the resistors. Okay. Now, when we check here, what are we asked to calculate? We are asked to calculate the amount of current. Now, remember from the previous video, we looked at this formula, isn't it? Now, is current the subject of the formula? No. Currently, the subject of the formula is R for resistance, and V is for potential difference, while I is the one for current. Now, if we are asked to calculate the amount of current, we need to make the I for current subject of the formula. So how do we do this? Now, some books have the triangle, whereby if you cover one, you get the formula for the formula that you want. But for me, I always just memorize the formula as it is. Then from there, I just make subject of the formula. As math students, you are supposed to be able to navigate through easily, okay, in rearranging formulas. So if you want to make I the subject of the formula, we can multiply I on both sides, which will cancel out on the right hand side. Then you are left with V equals to I multiplied by R. But I want I for current alone on one side, so I'll divide both sides by R. Then it will cancel out this R. Then I'll have I equals to V divided by R. Okay? So now if I know that I equals to V divided by R, what is the V? The V is the potential difference, and then the R is the resistance. Do I have those two somewhere in our statement or on our diagram? Yes. We have a potential difference of 12 volts, and we have a resistance of 6, which we calculated in the first question. So this is basically a carry-on question, meaning whatever you answer in question 1, your answer there, you need to use it to answer question 2. Okay? So now that we know that our potential difference is 12 volt and our resistance is 6, we substitute that into the formula. 12 divided by 6 will give us what? To give us 2. And then since we are calculating for current, we put the unit of current, which is ampere. Okay? So it's 2 amps. That's your final answer. So let me just drag this answer here. So let's quickly clean up here and try answering for C. Now C states, calculate the potential difference. Okay, so PD here means potential difference. I just didn't write it out in full, but it's potential difference across resistor 1. Okay, now you need to remember that the potential difference across different components in a circuit differs. I believe it's only the current that stays the same, especially like in a series circuit. Okay, so let's calculate the potential difference across R1. So what do? We come again in our formula here that we have learned of resistance. And then we ask ourselves, what are they asking for? They're asking for the potential difference. Now, what is the potential difference in our formula? It is the V, meaning we need to make V the subject of the formula. How do we do that? We multiply both sides by I, which will cancel out on the left-hand side, and we will be left with V equals to I multiplied by R. Okay? Now, if V equals to I multiplied by R, I stands for current. Do you have current? Yes, we have calculated the current in question B. Do you have the resistance? Yes, we have the resistance, but you have to be careful because now it says we want potential difference across resistor 1. Okay? So now you have to go to resistor 1. What is the resistance for resistor 1? So for resistor 1, the resistance is 2 ohms. Okay, so you substitute those two figures into the formula. So the current is the 2 ampere from question B, And then the resistance is for R1, which means is this 2 ohms. So what is 2 multiplied by 2? That will give us 4. 4 what? 4 volts. Okay? Since we are calculating for potential difference. That's our final answer. Now from there, just remember that V is potential difference. Let's quickly drag this guy and put him under the question. Good. Now let's clean up and come to D. Calculate the potential difference across resistor 2. So let me give you 5 seconds to try that one out, because it's basically the same as the previous question, which is C. So pause the video now and check if you get the correct answer. Okay? Okay. So calculate the potential difference across resistor 2. So what do? We always check in our statement, what are we asked to calculate? The potential difference across resistor 2. So we bring out our formula. In our formula, which letter represents potential difference? That will be V. Okay? So we need to make V the subject of the formula. How can we do that? We can do that by multiplying I on both sides, which will cancel out on the right hand side. You're left with V equals to I multiplied by R. Now, I is current. Do we have current? Yes, we have calculated the current in question B. We have 2A or 2 amps. And then, do we have the resistance? Yes. For the resistor 2, the resistance is 4 ohms. So we substitute those two figures into the formula and we will have 2 multiplied by 4. Now, what is 2 multiplied by 4? That will give us 8 volts. Since we are calculating for potential difference, the unit will be volts, okay? So, basically, that's our final answer. So, if you're not familiar with the formula for resistance, which is this R equals to V divided by I, check out the previous video, okay? So, with that said, let's bring this answer here. And thank you very much for watching this video. Please do like, subscribe, turn on that notification button not to be the last to see the next upload. Share with friends, family, and classmates. And remember, together we rise to higher heights, apart we all stay behind. Cheers.